And this morning, at least in Arizona, we are delighted to have as a guest speaker, Dr. William Lamb. Dr. Lamb began his studies in the University of Maryland, Baltimore, with a degree in psychology to later discover the love for the Celtic studies, which led him to pursue postgraduate studies and completing a Master's of Science in Celtic Studies in 1996. Began his PhD in linguistics the following year, concluding the same in 2002. Dr. Lamb is currently a senior lecturer in the section of Celtic and Scottish Studies in the University of Edinburgh, and his work includes countless efforts for the study of preservation of the Scottish Gaelic language, in which he has explored Gaelic music, speech, and register variations, and has worked on several projects on the topic of natural language processing for Scottish Gaelic. So, without further introduction, everyone, please welcome Dr. William Lamb.
Hello. Thank you very much for that wonderful introduction, Louise. So I'm just going to share my screen here, and hopefully we can do that without any issues. It's asking me for install a Zoom. I'm afraid that although we tried to do this before, it's now giving me problems.
I think you can just quit out of that. You're fine. You're good.
Yeah? Okay. Yeah. Oh, great. Okay, excellent. And that's advancing okay. Great. Well, just to say again that I'm really delighted to be here and virtually, and to say thank you again for the invitation. So today I'm going to be talking about emerging NLP for Scottish Gaelic. And NLP, if you don't know what that is natural language processing, basically language technology and kind of what's coming online for the language. Some of these things are things that I've been involved in, and some of these things are things that I use that other people have done, or just that I want to make you aware of. So I'm just going to advance, make sure this works. Okay, great. Well, natural language processing, or NLP, is often described as the combination of linguistics and informatics, or computer science. When you're working with a new language in NLP, it is usually a discussion between domain specialists, those who know the language well, and computer scientists. However, the more that your data grows, the more that you can cut out the language experts, as we'll see. I should say up front that my background is in Gaelic linguistics and ethnology. I'm not a computer science, although I can do a bit of coding. I'm planning to start a master's in speech and language processing next year for my sins on top of everything else. But at the moment, you know, I'm really a bit of a hacker when it comes to this stuff. I can get myself into trouble, and I rely on other people to be the experts when it comes to the computational stuff. So I see my role in Gaelic NLP as an active facilitator, although some of the work I've done has found its way into some of the technologies that I'll discuss. So if you're a computer scientist or if you're an NLP specialist, I might not be able to answer every question that you've got today, but I can certainly point you in the right direction. So, well, why is NLP important for Gaelic? The pandemic has catalyzed changes that were already afoot. A huge amount of our communication is either technologically mediated today, that is human to computer to human, or it has the computer as an addressee. With the rise of computational conversational agents, it won't be long until computers are prompting us for responses. And currently this tech is overwhelmingly geared to well-resourced majority languages. Gaelic is already a threatened language, so it stands to reason that you either open opportunities for using it in computational spheres, or English has an even bigger share of the linguistic real estate. Some of these tools can make really big differences to people. A few days ago, I received a comment from a mother with a dyslexic son about the speech recognition research that we're doing. And she described the research once the tools are made available as absolutely game-changing for her son, because at the moment, you know, with English, he can dictate into a computer and then get the computer to read it back to him. But he can't do that with Gaelic. He needs to type things in or get his mother to help him with the Gaelic. But then he can use KT, the Gaelic voice, the speech synthesis app that Sarah Proc developed to read it back to him. So if you had a way of inputting then that would kind of close the circle and just be fantastic for him. And I think that's a really poignant example of a real life use case of NLP technology for Gaelic. For me personally, this is the first branch of academic work that I've been involved in that's really got the potential of improving people's lives dramatically. And that makes it really meaningful, I think. Apart from creating new speech domains for Scottish Gaelic or replacing ones currently dominated by English, NLP has the potential to create new and better speakers of the language. The success of Gaelic Duolingo has shown the appetite for this. There are now, as probably you well know, over 600,000 people on Gaelic Duolingo. And if we can find ways to harness the linguistic and cultural knowledge that exists inside a highly competent native speaker and teach it in a learner-specific fashion, I mean, that could really transform the entire Gaelic language community. Although that vision and many of the other ones that I have about, Gaelic, it's currently science fiction. It won't be science fiction forever. And we've got the opportunity now to put Gaelic incrementally closer to those future possibilities. So the different types of NLP that you typically find, and Kevin Scannell might add a few here, these are just the ones that I came up with, but you see things like annotation, like segmenting text and classifying words' morphological features, things like analysis, building models of different kinds of text and comparing them against particular features, doing recognition, like speech recognition, or converting analog text to digital text using OCR or handwriting recognition. And then the last one, which is probably the most complicated one, language generation and understanding. So, building a chat bot or, an AI system that it can essentially, you can converse with it. Or it can, test your responses for pronunciation, idiom, and grammar. I mean, that would be fantastic for a Gaelic learner. So these are some of the different kind of general types of NLP that you might find. And I'm presenting these things really just for those of you who don't have a background in this stuff, or, like me, have a, you've got an awareness of it, but maybe need a little bit more information. So today's outline, the things I'm going to talk about are I'm just going to expand a little bit on the different types of NLP, and then we'll funnel down and talk about specific resources for the Gaelic language, and we'll talk about some of the apps that are available right now, and then some of the next steps. So the two main types of NLP, generally speaking, are, you could say that you've got text-based NLP, things that are, where you're dealing with digital text in one way or another, things like parse speech tagging, syntactic parsing, or machine translation. And then you've got audio-based NLP, things like speech synthesis or speech recognition. Within the way that you're processing or building these tools, you can divide them into things that are rule-based or statistically based. In the early days of NLP, almost all the programming was rule-based. So that means that, if you want to assign parse speech tags to a large amount of text, you had to tell the computer explicitly, line by line, how to do that. When Elaine Nigonoho developed the first POS system for Irish, she took that approach. And she was involved in the project that I led on Scottish Gaelic parse speech tagging, and she said, well, to be honest, you've got enough data there, I would just do a statistical approach, and that's what we did. So statistical approaches usually rely on large quantities of data, and the more information you have about the data, often, particularly when you're starting with a new language, the more useful it's going to be. So you're looking for annotated data if you can get a hold of it. But you also have approaches increasingly using things like neural networks that are utilizing non-annotated data. So, Google is obviously very fantastic at doing that. Google Translate pretty much just goes out there and, as far as I understand it, and crawls the web for parallel examples of, of text in two different languages and just kind of works out the meaning over time. We'll come back to Google Translate in a few minutes. So looking at text-based NLP, again, just kind of continuing this very minor tour de force on, a tour of no force on NLP and the different types that you might find, just to kind of adumbrate some of the things they'll talk about in a few minutes for Gaelic. We've got tokenizers, lemmatisers, speech taggers, syntactic parsers, and machine translation apps. So these are all examples of text-based NLP. So what's a tokenizer? Well, a tokenizer, given a stream of text as input, returns a list of tokens. So what's a token? Well, a token is whatever you decide is meaningful in a stream of text. And usually you're talking about words or just bits of words. In English, Gaelic, and many other languages, just splitting a text up using what's called white space, so things like spaces and punctuation, is often a good place to start. But it's not always helpful depending on what you want to do later on downstream. So if you look at the first example, the input is ha machain rauer, so my dogs are fat. The output being ha mo chain rauer, so that's dividing it up based upon the spaces. But depending on what the words are, you might need to do it a different way. So one way of tokenizing that, the second sentence, ha machain ashen, my dogs are there, might be to divide it up on kind of each bit of white space or each bit of punctuation. But then again, you might decide to have a tokenizer that that looks out for some multi-word expressions or some hyphenated words or whatever. So it's not always straightforward. Okay, so that's tokenizers. A lemmatiser basically takes a textual input and returns the lexical root of each token. So when we were working on developing our first kind of word embedding model, first kind of neural network for Scottish Gaelic in 2015, we found that data sparsity was a big issue. We used a collection of text that Kevin Scannell did for Gaelic and a ton of other languages through his Grúpadan project, and it was about, I think, 5 million words of Gaelic. So because Gaelic is a morphologically rich language, we had a problem with data sparsity, and we decided to lemmatize the whole thing to kind of get rid of more morphological features that we didn't need. So that way, when we inquired from the system, if we put in the word do for black and we were hoping it was going to come back with lots of other colors, that's exactly what it did. But if we hadn't lemmatized it, it would have struggled probably with that task because of the fact that in Gaelic, the word do, black can be do, it can be gu, it can be dui, it can be duya, it can be dua, and so forth and so on. So that's why a lemmatizer is quite useful. A part of speech tagger basically takes a textual input and returns tokens that are morphologically classified, obviously for parts of speech. So here we have an example where you've got a token, so ha na con voda an, the big dogs are here, or the big dogs are there, has been lemmatized, so you say bi, na, ku, mor, e. The last one you could do that arguably as an or an, but we won't worry about that. And then you've got some tags for each one of those words. So they've been tagged automatically for part of speech. The first one being a present tense verb, the second one being a definite article, and so forth and so on. So that's kind of what a part of speech tagger does. Moving on down the line, a syntactic parser, given a textual input, returns the information that you want about the syntactic functions of each token. So, for example, what's a subject, what's a predicate, what's a modifier, what's an oblique expression or whatever. So here's an example of that. So this is a Gaelic syntactic parser that's giving you that information, as well as part of speech tags. So the parsed information or the syntactic information on the right hand side, and then you can easily transform that into a tree diagram. So it can be quite useful from a theoretical perspective as well. And then finally, looking at machine translation, so it's just about taking the input of text in one language and then returning it in another language. Sorry, I forgot I moved on in my notes, but I didn't move on the slide. So this is the slide for the syntactic parser. And so you can see there on the right-hand side, you've got the different syntactic categories, and then at the bottom you've got the tree diagram there. And then just a slide that's not very informative about machine translation. Okay, So let's look just briefly at audio-based NLP. So here we're talking about really two main things: speech synthesis, or what, as it's also referred to as text-to-speech, and speech recognition, which is also referred to as speech-to-text. Okay? And that kind of brings us to the close of the different types of NLP that you find in different languages. Of course, there are other things out there, but these are kind of a lot of the core tasks that you might encounter. So let's now zero in on stuff for Gaelic. Today, as I mentioned, most NLP work is inductive, it's statistical. It uses statistical approaches to generate the tools that you want to use. So resources are really important. The more text you have, and the more kind of annotated text in particular that you have, the more useful your tools are going to be, or the more accurate they'll be. So we rely very much on things like digital lexicons, digital corpora, either annotated or non-annotated. So let's look at a few of these tools and what's available for Scottish Gaelic right now. One of the biggest ones is obviously a digital lexicon, and we're so fortunate that Michael Bauer, when I knew him actually, I mean I still know him, but when I first met him as an undergraduate, he started typing Dwelly's dictionary into a Word document because he thought this would be wonderful for people to have. He struggled with the publisher about making it available online, and eventually cracked that, and then of course developed this wonderful online dictionary. First Dwelly's, and then he started becoming a real lexicographer himself and developed FACL2. He provides obviously phonology, he provides morphology, and he provides information on semantics. He also gives you a lot of really good information on where people use particular words. So this is an exceptionally rich source for NLP. Now, the only problem is that Michael and Will set up their databases for the dictionary, not for NLP. So fortunately, we've got some pretty good data wranglers on our team, and I've even dabbled a bit on that, a bit with that. I converted their database so that we could use it for lemmatization. So let's take a look at some of the things that their wonderful dictionary has enabled. So I mentioned the Lemmatiser, based upon word forms. If you couple the word forms with morphology, then theoretically you could develop a grammar checker. You also could do things like spell checkers. It's been used for a speech synthesizer. It's been used for a spell checker. We can use the phonetic information that they've got for speech recognition, and again we can use the word forms for doing things like orthographic normalization. And I mean, that's a huge amount of stuff that we can get just from this one very rich resource. Somebody mentioned that they've been using the corpus that I put together. So this is ARCOSG, which stands for the Annotated Reference Corpus of Scottish Gaelic. This is an 84,000 word corpus marked up manually for para speech. So I worked on this for my PhD. I got a terrible case of RSI, typing in bloody para speech tags for 1 full year. I don't recommend that to anyone. The reason I did that was at the time I had a colleague who said he was going to develop a para speech tagger, but he got employed by a more lucrative employer than the University of Edinburgh and jumped ship just as we were beginning. So I was determined to do a para speech tagger. That's why, in a way, I got involved in this stuff. But anyway, this corpus is, started its life specifically for that project, but then we converted all the tags to a system that's used across Europe, the Parole tag set, and we had people come on board and basically retag the whole thing. It's been checked by 3 different people, myself and 2 domain experts, and there are now 2 different versions of this. One that uses a smaller para speech tag, para speech set that has 41 tags, and another with the full tag set. You also can import it into NLTK, so the Natural Language Toolkit. If you go into the, if you look on your handout, the PDF that I sent through, all of these all these hyperlinks are active. So you can get to the different URLs or whatever. So you can go on and look at these. And if you do import it into NLTK, you can also use the universal, what's called universal dependencies tag set, which is just like 12 tags or so. So there are lots of different ways of using this. Of course, if you just want to do linguistic research, you can just bang it into a concordance or like Corpus Workbench or AntConc or whatever, NLTK of course. If you're interested in doing lexical searches, then your best bet is really to go and look at Corpus na Gaelic, which is a subset of DASC done by the University of Glasgow, an absolutely fantastic online corpus of Scottish Gaelic. ARCOSG has been used for a few different things. It's been used obviously to train the Parse speech tagger, both the one that I developed first in 2013, 2014 with Sami Danzo, and then also one that we developed more recently, myself and Loic Boiso, who's a colleague in Lithuania. And I'll talk a little bit about that in a few minutes. So obviously it's great for doing that. You can also use it to develop a syntactic parser indirectly. And ARCOSG was also used to help develop the KT speech synthesizer. In terms of non-annotated corpora, you've got different a few different things. The GD corpus produced by Kevin Scannell as part of the Crubathon effort is absolutely great. It's great because it's just a huge amount of text. I mean, I think the text itself kind of varies in quality. Some of it's really, really good idiomatic Gaelic, and some of it is, kind of rough tweets and stuff. And that's in a way both its weakness and its strength. So that's one source. Island Voices, so this is a project that Gordon Wells did as part of UHI, and these are a ton of really good online videos that are Creative Commons. They've all been transcribed really well by Gordon, and it's just rich, idiomatic, modern Scottish Gaelic. So it's about 350,000 words presently. You can also get a hold of raw text from Corpus na Gaelic. You can download individual ones that are out of copyright, but you can't get the more modern ones. So it is a little bit problematic in terms of orthography and stuff. And we're working on a tool that will automatically update older orthography into kind of a quasi Gaelic orthographic conventions style of writing. A little bit similar to what Kevin did with his work updating things to the Coijon. I'm sorry about my Irish pronunciation, it really stinks. I have to remedy this sometimes. Currently available Gaelic NLP tools, well, they basically boil down to machine translation, speech synthesis, so text to speech, linguistic annotation, and handwriting recognition. And again, if you look on your PDF, all of these links work. So this should take you straight to the specific tools. So Intergaelic is a machine translation app that Kevin did. It's an online one that goes from Scottish Gaelic to Irish. It's specialist, but it's very reliable and transparent. It's really fantastic. And we're going to be using it hopefully for a super large project where we'll be using it to translate, I don't know, maybe 20 million words of Scottish Gaelic to Irish. Google Translate's an interesting one. When I first got in touch with Google for Bors na Gaelic in 2015 to see if they'd be interested to develop Google Translate, for Gaelic the response was, I quote, "There may not be enough Scottish Gaelic in machine-readable online form to enable good translation models to be built." So that was in January 2015. I sent them some data that I had gotten from someone else, and they presumably sorted the rest out with sources available on the internet. And by April 2016, it launched. It was, let's be honest, it wasn't great when it first launched, but sometime in 2018 or so, it improved almost overnight. And it's still a bit of a mystery to me how they did that. Now, it's really actually quite good. It's got some foibles. For example, some of the punctuation is off, but you can use it pretty reliably. a colleague in the University of Highlands in Ireland, Gordon Wells, who I mentioned before, wrote a really nice blog last week on Google Translate where he compared how it worked in 2016 to how it's working now in 2021. It's really striking. The Gaelic Linguistic Analyzer is the project that I did with Loic Bozo in Lithuania, and it tries to be a one-stop shop kind of web app. I'll spend a few minutes talking about it, and then I'll move on and talk about speech recognition. So if I click here, you can hopefully see. So you can just go on and use it to tag some text. I mean, I don't know. I don't think I've got any Gaelic text on my computer at the moment that I can pull in right away, but just show agus ami hulu dinne gama. Okay, so we can do full tagging and parsing. Let's just go ahead and do that. Sometimes the columns get a little bit messed up, but you can see
we actually can't see.
Oh, you can't see that.
Yeah, we could see the basic data entry box, but nothing typed into it.
Ah, that's a shame. Okay. Well, I think then I'm probably
sharing screen or sharing window. I think if you're sharing window, that might be the issue. You need to share screen, which unfortunately lets us see your screen.
Yeah. Okay. Let me just see. If I go to this, can you see it? Share. Can you see that now?
Yes.
Yes.
Oh, great. Okay. Let me just go back. Okay, I'll just do full tagging. It might actually work a little bit better. So, anyway, there, the linguistic analyzer just can tag things into a column kind of format. But you can also send crow requests to it. If you go into more about the analyzer, it tells you about how to do that. It's really not that difficult if you've ever used a terminal on your computer, or even if you haven't. It's pretty easy to learn how to do this. So you can send much bigger texts. The other thing about it, which is quite nice, is we've done it all bilingual. So I'm guessing that some of that probably has been crawled by Google Translate by now. But anyway, do check it out. It's all based upon ARCOSG, but we also got some stuff from Colin Batchelor. Some universal dependencies stuff, and Loic trained the parser on that data. Yeah. Anyway, so that's what I wanted to say about the Gaelic linguistic analyzer. Let me just see if I can go back to my PowerPoint. Can you see the PowerPoint again? Brilliant. Okay, great. So just click on that. Oh no. Okay, great. This shows you if you do send a crow request for using the conlu output. This is really nice, and this basically gives you it's a format that was developed for universal dependencies. But there you get the form, the lemma. You get the universal part of speech tag. You get the language specific part of speech tag. So that's the XPOS. You get the head, which is the head of the current word, which is either a value of ID or 0. You get the universal dependency relation of the head, etc. So it's a really nice, useful output format. How accurate is the part of speech tagger? It's pretty accurate now. When I led the project in 2013-14 to develop the first POS tagger, we got somewhere around, I think we maxed out around like 84% or something like that. Now with the full tag set, we get about 91% accuracy, and with the simplified one, which is still really useful with 41 tags, we get 95% accuracy. So it's definitely usable for a lot of tasks. Okay, so that's the part of speech tagger. I want to talk now about handwriting recognition. This is a project that we ran about a year and a half ago. With NLP, for a minority language, you're always going to be dealing with, as I said before, data sparsity. So what data can you get your hands on that's digital, that you can begin to use to train different NLP tools? Well, with Gaelic, obviously it's limited, but there's a ton of stuff in the School Scottish Studies archives that's both in handwriting and is also that, typed out. So we started a project where we began first scanning stuff. So we took 2,000 pages and we scanned all of it. And then we built a handwriting recognition algorithm to basically recognize this stuff. And we did it using Transcribus, which is a really mature tool now. It's an online app, and you can also get it as a desktop tool. So how well did it go? Well, we got an RA to manually transcribe for about 2 working weeks, producing about 10,000 words of text or 118 manuscript pages. We then used that to train a recognition model, and we transcribed 200 pages with that model, which the RA then corrected. After that, we built another model, and on that third, or actually only second iteration for the tool itself, we achieved for our primary hand a 95% accuracy rate. And that meant that we were able to basically quadruple or quintuple the output that we would have had just using manual transcription within the 8 months of that project. So obviously if it had gone on longer, then it would have probably, I don't know, who knows, it would have been logarithmic or whatever. We were able to transcribe and check 376,000 words by the end of the project. So all that now is fantastic training data. This is the workflow for that. I'm not going to go into this in a lot of depth right now. Just to point that out, you can have a look on your handouts for a bit more information. I give you here the different accuracies. So CER is character error rate, WER is word error rate. If you look here, the P is for the primary hand, the O is for all the hands. There's a predominance of one hand, so that kind of skews it a little bit. So we're getting on all the hands 14% or almost 15% word error rate. The character error rate's a bit better. But even then, at 85% accuracy, it's still really useful for doing this kind of work. And of course, if we spend a bit more time increasing the number of hands, it would all become even more useful. So I'm going to finish by talking about the Gaelic Speech Recognition Project. And this is, I think, one of the most exciting things that I've ever worked on. Our goals are to automatically transcribe Gaelic narrative audio. So basically, again, to fold this type of work back into doing humanities work, because we've got so much of really, really interesting transcriptions being held by the School of Scottish Studies archives, but we've got a lot of stuff that isn't transcribed. We've got tons of audio that isn't transcribed. So wouldn't it be great, rather than paying people to do that, because it's so difficult to get grant money to do that, to do it automatically. So that's what we're aiming to do with this. We're also aiming to produce an orthographic normalization tool, the one I mentioned before, to enable rapid inclusion of digitized texts into different NLP training pipelines. And we're also hoping with this project to aid Gaelic revitalization by increasing the speech domains that exist for Gaelic speakers. The components of the system are an acoustic model, a lexicon, and a language model. A lexicon is quite specific here. We're talking about a list of words with their phonetic pronunciations. So we use Michael Bauer's database, and fortunately he gives us IPA transcriptions for about 40,000 words. I mean, the guy is he's a force of nature. I mean, how he finds the time to do this stuff, it's incredible. So that's a really important component. Another is a language model. And what a language model does is it, well, given a sequence of words, it predicts the next most likely word. So if you say the United States of, the language model should be able to tell you in English, America. An acoustic model works by, giving an input of speech audio. It predicts the most likely phoneme sequence. So if the input is, good morning, it's going to produce a sequence of phonemes that link to that input. The resources that we've used for this are, well, to produce the language model, we use textual data, we've used the phonetic lexicon for the acoustic model, and for the acoustic model, we've also used audio and transcriptions. So the training data that we have, we've got a whole bunch of stuff from Topin and Dulcish or Kist of Riches, transcriptions that they've done independent of this project, and amounts to about 315,000 words or 18 hours of audio. For the handwriting project that I mentioned, we've got near enough 400,000 words, about 20 hours of audio. The Island Voices project has given us about 300,000 words. These are all kind of rounded off, and about 22 hours of audio. The GD Corpus, thank you again to Kevin Scannell for that, another force of nature, and that's 5.7 million words. Then the Callum McLean project Corpus, which we haven't ingested yet because it's pre-normalized, that's about 1.2 million words. But that is key to the success of this project, because that is all absolutely fantastic traditional narrative recorded back in the 1940s. The audio was white back then. It was all done on wax cylinder, and to conserve the wax cylinders, they just recorded it, transcribed it, and then wiped it. So the stuff that we've currently used is about 6.3 million words or 40 hours. The whole amount that we've got is 7.9 million words and 60 hours. For training a state-of-the-art speech recognition, platform or whatever, these are really small totals. So we need to kind of, rein in our expectations, but still, it's going pretty well, as I'll show. One of the difficult things is normalizing text. So we need to get rid of punctuation. We need to get rid of all this junk, capitalization, digits, unspoken text. So this is important both for the language model and the acoustic model. So try to remove as much of this kind of extraneous stuff as possible. We've also, as part of this, taught the computer how to verbalize numbers. So if it's given 1860, 1860, it knows to change that to Orchiet. So these are all some of the things that need to happen under the hood.
Oh no.
Looks like we've lost Will. We'll see if he comes back in. I will send him a message. Feel free to type in questions you might have for Will into the chat box while we try and get him reconnected.
Oh, there he is.
Oh, good. I'll need to make him re-co-host him.
Fantastic. Okay, thank you.
Are you back?
Yeah.
You'll
Okay,
need to reshare.
Is that working okay? Can you see the screen again? Fantastic. Okay. So we're just talking about some of the things that we need to do to get the text into shape. Now, because we've got a ton of, or a reasonable amount of transcribed audio paired with original, I should say transcribed audio, so transcriptions of audio paired with the original recordings, we can train acoustic models using what's called forced alignment. I'm just going to have to jump ahead here a little bit because I want to play some stuff to you. But basically the idea here is that we can train a model to link the text to the audio and do that really rapidly and do that very accurately. So that enables us to do various things. I mean, underneath the hood of that, we have to do Phoneset mapping. So we need to go from, a word to IPA, then to a more standard IPA, then to what's called ARPABET, which is a kind of a crazy English-based phonetic system, and then to the system that's used by Quarit, who we've worked with. So this is just one of the things that you need to do. We've developed what's called a grapheme to phoneme model to do this. So if you input, say, Hushkenen, then it'll come out with this series of stuff. And that AX is not ach at all. It's a code that's for a particular vowel in English. So we've used English models to bootstrap some of this stuff. And it's enabled us to do automatic subtitles. That's one of the first outputs of this. So I'll just play this so you can see it. So this is using forced alignment to take transcriptions and bang them in or link them to the audio and then produce automatic subtitles on the back of that. And this is a really exciting kind of, already almost mature development of this project. And this has only been going since September. So I'm really excited by this. The Gaelic Television Service has gotten in touch. They want to do some work with us on this. We've done subtitles for all of Gordon Wells' videos on the Island Voices project, and you can find the URL for that. The other thing that you can do this, which I won't show you, is but if you go on and click on the automatic translation thing there in the PDF, then you'll be able to select English subtitles for the Gaelic videos because Google Translate runs underneath YouTube. So suddenly all these videos that are in Gaelic can also be translated into Albanian, Arabic, and of course English or whatever. Speech recognition is a more complicated task. So you again going from inputting speech, you're going to an acoustic model, and then you're using a lexicon and language model to kind of constrain it and predict what those sounds would be in terms of words. And I'm absolutely delighted to show to you for the very first time our Gaelic ASR system prototype. So this is a world premiere of this. It's getting somewhere between 70 and 80% correct on this. So here you go. Okay, so that's a world premiere of the Gaelic ASR system. It's not perfect. There's no punctuation. It's missing words, but it's doing a really good job for something that we only started in September. So I'm pretty floored by this. I think that already this could be useful for that dyslexic child, particularly with pretty simple Gaelic. It would do a reasonable job. So the next, so the ASR training, this is only based upon 20 hours of speech data. It's a tiny amount. We're in the process of training a new neural network model. These are Gaussian mixed models. Due to lack of time, I'm not going to talk very much about that, but they're getting, at best about 60% correct or so. We expect the neural network that we're training at this moment, which also includes, it basically doubles the data. We expect that to do an even better job. So I'm really excited to see how that goes. The next steps are to use the tool to transcribe archive recordings, iteratively improving it. Of course, to make it available to you guys and to people in Gaelic Medium Education, to everybody. We certainly plan to do that by the end of the project, around in August. And we want to get more funding. And one of the things that I'd like to see is to create a portal similar to the wonderful stuff they've done at DCU, Dublin City University, in collaboration with the UCD, crowdsourcing transcription of folklore manuscripts. So it'd be wonderful to do that with Gaelic recordings, so that we can, provide that data, but also to make this tool even better. If you want more information about what's going on with Gaelic NLP, you could check out our blog at the Gaelic Algorithmic Research Group, or GARAC. You can look at the Twitter feeds for myself, Kevin Scannell, and Michael Bauer. You can look at the proceedings of the Celtic Language Technology Workshop. I've given you links there, 1, 2, 3. And I'd like to just acknowledge Lucy Evans, who's on our project team, for sharing some of her slides and text regarding the ASR tools. And also many thanks to the funders that we've had since we began this work back in 2013 or so. So thank you very much, everyone. Sorry for the blip in the middle there.
All right, thank you, Dr. Lamb, for this excellent presentation. I will proceed now with the questions that the people in the chat have written throughout the whole presentation. So, first question from Mike Hammond: can you elaborate on audio/speech resources? I don't know if Mike wants to.
Sorry, that was. I think that was superseded by later information. So you started talking about text resources. I started thinking about audio resources, but then you explained. And I'll just take this second to say, awesome, dude.
Thank you, Mike. Thanks very much.
I have more questions, but I'll wait for Luis to get to,
All right, second question by Andrew Supon: how do you evaluate the quality of non-annotated corpora like the GD Krubadan corpus?
Well, you have to annotate it. I mean, there's no way of doing it. We've used what's it called again? Come on, Will. Elan. So Elan is a transcription tool, and you can use it to very methodically align audio and text. And so we've had Michael Bauer go and take a subset of the corpus, which is our eval set, and very precisely align it so that we can check that our tools are working. So if we wanted to use, for the speech recognition task, the GD corpus wouldn't really be salient because there's no speech attached to it. There's no audio. But for another task, you would probably need to, annotate it or make it informative somehow.
Right. Next question by Andrew Zubon as well. The ARCOSG corpus contains text from different spoken and written domains. Do you see different performance on part of speech tagging for the different domains? Are they all run together or separately?
That's an excellent question. We've never actually evaluated it against the different domains, but that's something that we should do. Yeah, that's a good point.
Okay. Next question by Mike Hammond. Using dictionary audio means you can't use a E2E model, right?
You can't use end-to-end, is it? Yeah, that's right. We've talked about doing that, but at the moment we can't do that yet. And I think as well with an end-to-end model, you need a ton of data, don't you?
Right.
Yeah.
I mean, so it's kind of moot, right?
Yeah, I mean that's what Google does, but yeah, obviously we're not Google. Although maybe Google will at some point decide that Gaelic is really lucrative and buy out Quorit and we can all retire to the Bahamas. Somehow I doubt it. I don't think that's in my future. Thanks, Mike.
The next question I have here is from Gostam Powell. Do you have F1 scores per part of speech tag?
Yeah, we do. We publish them. I mean, if you go and look at our article from whenever it was, 2015, you can get them from the first version of the Power Speech Tagger. The more recent one, I need to double check. We did do a poster session last summer, but I don't know if Loic is. I don't remember if he actually put out F scores. But you could write to him easily if you wanted that information. I'm sure he's got it. I can't give you them right off the top of my head though.
All right. Next one I have here is, well, what is the relative quality of tools built in low resource conditions for an endangered language?
Yeah, sorry. Let me reword the question. It's a spiritual question, and it's really for everybody, right? But I'll ask you, right? So imagine you're a kid. You have a choice between speaking Gaelic and speaking English, and you go to your computer to do some task that requires you interact with some NLP software, and you have a chance to use some product that Google makes based on bajillions and jillions of hours of training data or whatever the task is, right? Or you have a choice of using a Gaelic tool or a Welsh tool or whatever the minority language is. And those guys have done the best they can with the data they got, but as a consequence of the data they have, the tool will not perform as well.
Yeah.
Question mark.
Well, that's certainly true. I mean, you're dealing kind of with the same problem that you've got with publishing. You know, is a kid going to pick up a book? Is he going to pick up Harry Potter in Scottish Gaelic or Irish, or is he going to read it in English if he's got that language? I think that we are in some ways fighting a losing battle here. At the same time, it's a battle worth waging. And I think that as long as people decide to speak minority languages, then there will be a place for these tools, even if they're not quite as good as the stuff that Google does. So that's my off-the-cuff kind of answer. I think the other thing, though, is like in terms of the value of them is they, I know with like Duolingo and I know with Gaelic Translate, Google Translate for Gaelic, these are really big deals for the language community, and they kind of they give a stamp of approval to the language that wasn't there before for the native speakers and the people that are habitual users or semi-habitual users, that these languages are on the map. They're still on the map. They're still relevant, and people want to do stuff with them, and so that makes us feel a little bit better about speaking them to each other. It's cool. It's robotic. It's modern. It's AI.
Oh, excellent.
It's sexy,
Excellent. Thank you.
Sure.
All right. Next question is from Gossan Powell. Is the ARPABET comprehensive enough to cover the set of phones here? My recollection is that the ARPA developed for English specifically and hasn't been expanded for other languages.
That is absolutely right. We used ARPABET and the Quora Phoneset really just to bootstrap the whole thing, so that we could use the really mature tools that existed within Quora to do the forced alignment. But we are now getting to the stage that we can do an entirely Gaelic acoustic model. So that would be one of the next things that we do. So just chuck out all that intermediary gunk that we use to bootstrap it and come right back around and have it all kind of natively Gaelic. So yeah, ARPABET is, we were joking about it. If you were to use the model that we had and convert it into a text-to-speech system, it would probably be like an American-speaking Gaelic with a really bad American accent. Kimmer how, it's Misha Will Lamb, agus Hami Fudok an and Donation. It would just sound terrible. So it's never gonna be useful for that. But it did allow us to crack the code for doing the forced alignment.
All right. Following next question. The Kitschith text-to-speech is really good. Do you know whether there is any likelihood being made fully public domain in the future? By Kevin Donnell.
Oh, so this is Kevin asking about the text-to-speech, the KT one, is it?
It's really amazingly high quality. It's freely available to Scottish schools, and I think in practice it's practically available to anybody who asks for it. But it's not, if it was really public domain, then the likes of Google could use it, and it would be there as a little button in Google Translate and lots of other systems. But I suppose it's up to the Scottish government giving more money to the company that developed it.
Yeah, I know. I wish it were, open access or whatever as well. I don't know if there are any plans afoot at the moment for pushing that forward, but we've talked about doing some things with Cereproc in the future, so that might be one of the things that we do. Maybe improving upon that and doing something that will be freely available. Who knows? But if I do get a chance to speak with, I don't know if is it Peter Bell, I can't remember who's at Cereproc, but yeah, I'll ask him that question.
All right. Following question by Andrew Supon. For all these tasks, both text and acoustic based, how do you control for dialectal variation?
You don't, not right now. But there might be, the possibility of doing that in the future. I mean, if you can imagine a pipeline where, like, let's say you're dealing with Argyllshire texts, which are Argyllshire speakers who are, quite different from Outer Hebrides speakers, and you wanted to do something that was more accurate for them. Well, I mean, you could train a model specifically to them. That's certainly feasible. And you could have, at the front of your pipeline, you could have a dialect identification, module or something, and then it would split off into the Argyllshire, dialect model. It's certainly possible to do that. But currently, we're not doing that, and we're kind of relying on the language model to disambiguate stuff. I mean, just, having a good sense as to what this should probably look like at the end of the pipeline. It doesn't really matter, hopefully, what the dialect's like. But in practice, I think that it's going to do really well for South Uist, for North Uist, for Bebecular, for Harris, probably reasonably well for Lewis, probably okay for Skye, and really not so well at all for dialects like Tyree, not to mention, East Sutherland or any of the peripheral dialects is probably going to struggle with them.
All right. Next question by Mike Hammond. Are you using Caldi type system for ASR?
Yep, we're using Caldi. If I hadn't run out of time there, I was going to mention that. Yeah, it's Caldi.
Okay. The last question I have here by Kerry McCullough. What kind of work tasks did you do on these computational projects when you had limited or beginner's knowledge of the skills, especially when you first started out?
When I first started out, I didn't know anything about NLP. And I mean, I guess I'm one of these people who decided that I would learn best by really throwing myself into the sharks. I can tell you there are a lot of scars on my mental body from this experience. You have to have a really brass neck to do this stuff with a minority language, becoming part of the community and all that. But I think, when you don't have that much knowledge, then you just use the tools that you've got and you use them to increase your knowledge. But I have yet to convince any NLP person to learn Scottish Gaelic. I'm working on a few of them. I'm hoping that I can do that. And I've gotten so sick of it that I've decided that I'll just have to be that person and I'm going to have to go away and learn NLP a bit better. So yeah, I don't know. I mean, when you're starting out, then start with some small tasks. Go into the NLTK, learn a bit of Python. Go onto the Natural Language Toolkit. and start playing around with ARCOS. Try to train some models, use them to learn the language a bit better. Try to train a word embedding model and inquire for different types of categories. Look at different adverbs. Look at different adjectives, and start using it as a thesaurus or something. I mean, there's all kinds of stuff that you can do that's really playful with NLP.
Well, that's the last question I have on my list. If anyone wants to ask something else, type it in the chat and unmute yourself and ask.
There was a comment from Cahill.
Oh.
It's in the chat.
Is that the Cardamom project one?
Yes.
Yeah, cool. Cahill, do you want to talk about that for a second? Do we have time?
5 minutes.
Okay. Is Cahill there? Maybe not. Well, that sounds really interesting. I will definitely be checking that out. Oh, I'm not involved. Just something I came across. Okay, cool. Well, I'll definitely.
Well, it's me, Doris. Sorry, can you hear me?
Yeah.
I'm not sure Cal referred to the Cardamom project. That's what I'm currently working on. But I wasn't paying attention. I had to do something at the last minute. So what was the question in relation to the project?
I don't think it was a question. It was more just a statement to make people aware of it.
Okay, yeah.
Delivering cross-linguistic similarities and between Celtic languages. I mean, that's a really interesting area. Again, we bootstrapped to using English models with this, but if we had had access to Irish stuff, it would have made an awful lot more sense to go down that route.
Yeah, I'll probably follow up with an email. I have to go in a minute, but yeah, thanks for the talk. Got to meet a Margaret.
Meet a tank.
Actually, I have another thought, and that is that when you were mentioning the audio data, what I immediately went and checked is the Common Voice website to see whether they had any Gaelic data, and they don't. But they're an interesting operation, right? So what they're doing is they're collecting these, it's just for audio, but there are presumably other sites like it, but they're collecting these audio samples for different languages. Some of them are huge, some of them are teeny. But what's nice is that a number of projects, are now building recipes that work with Common Voice. So, for example, there's an ASR, speech processing project called Speech Brain, and they just went live a couple of days ago, and I've been playing with them. And most of their systems, they have recipes for the Common Voice data. What that means is you can build an ASR system for French, flip a switch, and you build it for Basque. Flip a switch and you build it for Spanish. I mean, the data sets are different sizes, but it really provides, the fact that people are building these recipes for Common Voice really gives us, how to put it, a chance to sort of take advantage of each other, right? To sort of build on each other's work. And it's just something you might think about for your audio data, whether you want to make common cause with them.
That's a really good idea. We could probably do that with the Creative Commons stuff anyway. Yeah, cool. I'll make a note of that.
Yeah, just a comment from here, Will. We're happy to share all of our video and sound and transcription data with you as well. I'll contact you after the talk with the details.
Brilliant. Thanks, Andrew. Yeah. I think there's definitely stuff we can do there. Fantastic. Hello, Pishak.
Cronin.
That's a good name.
Anyway, I think it's time for us to wrap this up. Thank you, Will. Thank you, everybody, for attending. We will be posting the video and the handout on our website And as Luis mentioned earlier, the next 2 weeks there is no FACL meeting, but then we're meeting after that. Please come to WCFL or SAIL. So let's thank our speaker and our tech team. Don't forget about our tech team.
It's a tech team.
All right. Thank you, Will.
Thanks, Andrew. Thank you, everyone. Take care. Slán.
Fine, guy, will it?
Cílíonn Drasta.
You're right.